Here we have a SAT math problem. Okay, let's go to the question. The functions f of x and g of x are both quadratic functions and m is a positive constant. The parabola formed by the graph of y equals to f of x has a vertex with a y coordinate of 3m. The parabola formed by the graph of y equals to g of x has a vertex with a y coordinate of m. If f of 10 equals to f of 14 and g of -3 equals to g of 27, for how many values of x does f of x equal to g of x? A, C, J and L are constants. Okay, in this question, first we have to be clear on what we have to find. We have to find the number of values of x for which f of x and g of x are equal. Okay, from the given two quadratic functions, when I equate f of x and g of x, I'll be getting an equation in terms of the variable x. When I solve the equation for the variable x, that is the x coordinate at the point of intersection of the graphs of the given two functions over here. So to find the number of values of x for which f of x and g of x are equal, I have to find the number of points of intersection of the graphs of the given two functions over here. Okay, now let me consider the information we have over here, that is f of 10 equals to f of 14, and also there is another information, that is y equals to f of x. That is, this f of x gives a value of y. Then this is the value of y when x equals to 10, and this is the value of y when x equals to 14. Okay, here for the quadratic function f of x, for two different values of x, we have the same value of y. In a quadratic function, for two different values of x, when we have the same value of y, then the average of the two values of x is equal to the x coordinate of the vertex. Okay, now to get the x coordinate of the vertex of the quadratic function f of x, we have to find the average of these two values of x, 10 and 14. Okay, now let me find the average of these two values. Let me add them and divide by 2. Then I'm getting 24 divided by 2, that is equal to 12. Okay, here I got the x coordinate of the vertex of the quadratic function f of x. Okay, let me write over here. So for the vertex, we have the x coordinate 12, and we have information about the y coordinate for the function f of x, that is 3m. Okay, now let me write it over here. And let me do the same thing for this information. We know that y equals to g of x, that is g of x gives a value of y. So this is the value of y when x equals to -3, and this is the value of y when x equals to 27. Here for two different values of x, we have the same value of y. In the quadratic function g of x, then the average of these two x values is equal to the x coordinate of the vertex of the quadratic function g of x. Okay, now let's get the average of these two values. That is -3, positive 27 divided by 2, that is equal to 24 divided by 2, that is equal to 12. Okay, let me write over here. For the quadratic function g of x, the x coordinate of the vertex is 12, and we have the y coordinate of the vertex over here. For the function g of x, the y coordinate is m at the vertex. Let me mark it over here. Okay, here I got the vertices for both the quadratic functions f of x and g of x. Now let's consider the x coordinate and y coordinate of the vertex of the quadratic function f of x. Both of them are positive. We know that 12 is positive, and there is an information that m is a positive constant. So 3 times a positive constant is a positive value. Okay, here both the x coordinate and y coordinate are positive, the vertex of the quadratic function f of x. Then we have the vertex of this quadratic function in the first quadrant. And now let's go to the x coordinate and y coordinate, the vertex of the quadratic function g of x. Here the x coordinate is positive, and we know that m is a positive value. So here also both x coordinate and y coordinate are positive. We have the vertex of the quadratic function g of x in the first quadrant. So both the vertices we have in the first quadrant of the xy plane. Okay, here let's consider the leading coefficients in both the quadratic functions over here. Leading coefficients means the coefficient of x square a over here, the coefficient of x square j over here. Now let me consider the leading coefficient of f of x, that is a. If a is greater than 0, then the parabola will open up. If a is less than 0, then the parabola will open down. For example, let me assume a is less than 0 for f of x. Then the parabola we get for this quadratic function will open down and will have the vertex in the first quadrant. And let me assume the leading coefficient for g of x, j, is greater than 0. Then the parabola for g of x will open up. Then the two quadratic functions intersect in 2 points. So that is, for two values of x, f of x and g of x are equal. We can say answer choice B is correct, but I do not know. So here to do answer further this question, we need to know the values of the leading coefficients, so that we can know whether the parabolas open up or down. Okay, how can we know whether the value of a is positive or negative? This value of j is positive or negative. Okay, for that, let's consider a quadratic function in standard form. That is, say, h of x equals to ax square positive bx positive c. When we have a quadratic function in standard form like this one, there is a formula to get the x coordinate of the vertex. For that, we have to take a negative sign and take the coefficient of xb, and it has to be divided by the coefficient of x square, that is a. Okay, now let me take the quadratic function f of x, that is f of x equals to ax square positive 36x positive c. Here we have the quadratic function f of x in standard form like this one. So we can use this formula to get the x coordinate at the vertex of this function f of x. Okay, now let me write it. X equals to negative the coefficient of x, that is 36 divided by the coefficient of x square, that is a. So this is the x coordinate at the vertex of the quadratic function f of x. But already we got the x coordinate at the vertex of the quadratic function f of x, that is 12. So we can equate this negative 36 over a and this 12. Okay, now let me do it. That is negative 36 over a equals to 12. Okay, now let's take reciprocal on both sides and we get a over negative 36 equals to 1 over 12. Now let me multiply both sides of this equation by negative 36. Let me do it on the right side as well, negative 36. Okay, here this negative 36 will cancel out, and here 12 goes into 12 one times and 12 goes into 36 three times. We have a on the left side, here 1 times and negative 3 equals to negative 3. Okay, here I got the leading coefficient of the quadratic function f of x, that is a equals to negative 3, which is less than 0. Then the vertical parabola we get for the quadratic function f of x will open down. Now let me do the same thing for the quadratic function g of x. Okay, let me take it over here. That is g of x equals to jx square negative 57x positive L. Okay, now let's get the x coordinate of the vertex using the same formula. Negative, and the coefficient of x is negative 57 divided by the coefficient of x square is j. Then negative times negative will be positive 57 over j. This is the x coordinate at the vertex of the quadratic function g of x, but already we got the x coordinate for the function g of x, that is 12. We can equate this 12 and 57 over j. Okay, now let me equate it. 57 over j equals to 12. Now let's take reciprocal on both sides of this equation. Then I'm getting j over 57 equals to 1 over 12. Now let me multiply both sides of this equation by 57. Let me do it. Then 57 will cancel out. Then we get j on the left side. On the right side, 1 times 57 is 57 divided by 12. Okay, here I got the leading coefficient of the quadratic function g of x, that is the value of j. So j equals to 57 over 12. It's a positive value, so greater than 0. Since the leading coefficient of the quadratic function g of x is positive, then the vertical parabola we get for this function g of x must open up. Okay, now let me erase some stuff and continue the problem. Already we know that the vertices of both the quadratic functions in the first quadrant. Okay, first let me draw an xy plane over here. Okay, here we have axis and here we have x-axis. Let me mark them, x and y, and also let me take the value 12, because 12 is the x coordinate at the vertex of the quadratic function f of x and g of x as well. Okay, now we have to decide where we can have the vertex of the quadratic function f of x and the vertex of the quadratic function g of x. Let's compare the y coordinates. We know that m is a positive constant, that is both the y coordinates are positive, and we know that 3m is greater than m. So the vertex of this quadratic function f of x must be above the vertex of the quadratic function g of x. Okay, now let me take the vertex of the quadratic function g of x over here, that is 12 comma m. Then the vertex of the quadratic function f of x must be above this vertex, so it has to be over here somewhere else, that is 12 comma 3m, because the value of the y coordinate 3m in quadratic function f of x is greater than the value of the y coordinate m in the quadratic function g of x. And we know that for quadratic function f of x, we get open downward parabola. Okay, now let me sketch the parabola over here. And for the quadratic function g of x, we get the parabola that opens up. Okay, now let me draw it over here. Here we have sketched the graphs for both the quadratic functions. Now we have to look at the points of intersection of both the graphs. Okay, here we have a point of intersection and here we have a point of intersection. Okay, the graphs of the given two functions intersect at 2 points. Therefore, there are two values of x for which f of x and g of x are equal, and we find this stuff in answer choice B, that is exactly 2. The correct answer choice for this question is B.